Hi class. All right, today is session 2 for fractions as division. All right, so if you don't have your book with you, pause this video and you should go grab your book. All right, make sure you open up to page 379. I'm gonna write that right here where you guys can see it. Okay. All right, we're gonna start with our problem of the day. This is just like yesterday. All right, Jared, Monica, and Heather have 5 hallways to decorate for the student council. All right, if they share the work equally, how much will each student decorate? All right, I'm gonna read it one more time. Jared, Monica, and Heather have 5 hallways to decorate for the student council. If they share the work equally, how much will each student decorate? All right, so in class, the first thing I would always ask you is, what are we talking about? All right, and we are talking about students decorating hallways, okay? Next thing I would ask is, what are we trying to figure out? All right, my question is, if they share the work equally, how much will each student decorate? All right, so now I have to go into the problem and figure out the important information I need to solve that question, right? Solve that problem, all right? So right here, I know there's 5 hallways to decorate, all right? So I'm gonna circle that, okay? And also, if they're sharing the work equally, all right, I need to know how many people are sharing the work equally, all right? So it says their names, Jared, Monica, and Heather. All right, I'm gonna put a 3 over here because that's 3 people, okay? All right, so equally is also an important word. All right, so when I'm sharing something equally, all right, I usually know that I'm going to be doing a division problem. All right, so there's 5 hallways to decorate, all right? And we're sharing that work equally among 3 students, okay? All right, so usually I would like to draw a model for this to solve it, okay? You guys might be able to solve it just by looking at this, right, from what we learned yesterday, but I'm gonna show you how a model would look like, okay? So I'm going to draw something that represents the 5 hallways, right? So here's hallway 1, okay? Here's hallway 2. Here's hallway 3. Here's hallway 4. And here's hallway 5. Okay? All right, so I'm gonna pretend that Jared, Monica, and Heather are working together, right? They are starting on hallway 1. All right, so here's Jared's part, here's Monica's part, and here's Heather's part. All right, so they finished hallway 1. They're going over to hallway 2. All right, and they're dividing the work up equally. So here's Jared's part, here's Monica's part, and here's Heather's part. Hallway 3, Jared's part, Monica's part, and Heather's part. Same thing for 4. And then I move on to hallway 5. Here's Jared's part of the hallway, here's Monica's part of the hallway, and here's Heather's part of the hallway. Okay, so now I have a picture, all right? So remember, my question is, if they share the work equally, how much will each student decorate? All right, so if I look at hallway 1, each student is decorating 1/3, right? There's 3 parts, and each student gets 1 part. So Jared's doing 1/3, Monica's doing 1/3, and Heather's doing 1/3. So each student for hallway 1 is doing 1/3. Hallway 2, same thing. They're each doing 1/3. There's 3 parts, right? And each student is doing 1 of those parts. hallway 3, hallway 4, right, and hallway 5. Okay, so I'm going to add up my fractions to figure out how much they painted all together. All right, so when I'm adding fractions, if the denominator is the same, I don't have to do anything. All right, still talking about thirds. All right, I just add the numerator. 1, 2, 3, 4, 5. Okay, so I know, all right, that each student decorated 5 thirds. Okay. I would definitely accept this answer, but I do encourage you guys to fix it. All right, this is an improper fraction. An improper fraction is when the numerator, all right, is bigger than the denominator. So I'm going to turn it into a mixed number. All right, so another way that you could do this, right, is to think how many times can 3 go into 5? All right, 3, 6, that's going over, so I know it can go in 1 time. All right, 3 times 1 is 3, so I'm subtracting 3 from the numerator. 5 minus 3 is 2. All right, and I keep my denominator the same. So we can say that each student decorated 5 thirds, okay, or 1 2/3. And this was, I was getting the answer with doing the model, all right? If you didn't need a model, you could have just done it 5 divided by 3, all right? And I would have gotten the same thing, right? This would be my numerator, my dividend is my numerator, all right? This is my denominator, the divisor, all right? See how I got the same thing? I could have turned it into a mixed number because it's an improper fraction. 3 goes into 5 1 time. 3 times 1 is 3, so I subtract 3. 5 minus 3 is 2, and my denominator stays the same. All right, so I kind of told you 2 different ways, right? You can use the model and do it that way, or do the easy way, just do 5 divided by 3. All right, same thing. All right, I'm not going to go over this again because this is basically what I did, and I don't want to confuse you too much with adding the number line in right now. All right, so going on to this page, all right, we're just going to do up to 4. All right, how many thirds of a hallway are there to decorate in 5 hallways? All right, it says blank thirds. So I want to know how many thirds there were to decorate. Well, if you look at our drawing, right? This is a third, this is a third, this is a third. So I want to know how many total thirds there are to decorate when I split it up equally. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 thirds. All right, so on this page, you're gonna write 15 thirds. Right? How many thirds of a hallway will each student decorate? All right, well, we figured that out already. Each student, okay, decorates 5 thirds. All right, that was our answer before we turned it into a mixed number. Write this as a fraction. All right, so 5 thirds, if I'm writing that as a fraction, I would write 5 thirds just like this. So they did 5 thirds of a hallway. Write a division equation that shows the quotient as a fraction. All right, so I'm going to write a division equation. All right, so here's my first number, here's my dividend, 5 divided by 3. All right, and I know that equals 5 thirds. Okay, it says write a multiplication equation to check this equation. All right, the opposite of division is multiplication. All right, so I usually start with my answer to the division problem when I'm writing a multiplication problem to check. All right, I would do 5/3 times 3 equals 5. Okay, so looking at this, you might not know that 5/3 times 3 is 5, so I'm going to show you how I know that this is true. All right, so 5/3 times 3. All right, when you have a whole number, you can just put 1 underneath of it, okay, to be the denominator. All right, 5 times 3 is 15. 3 times 1 is 3. All right, well, this is an improper fraction. So how many times does 3 go into 15? 5 times, okay? So, and that's what I got. So I know that I did this correctly. All right, how many whole hallways can each student decorate? Well, I know that each student decorates 5/3, and this is an improper fraction. All right, so I need to figure out how many whole hallways. So that's the whole number I get. 3 goes into 5, I already said, 1 time. All right, so each student can decorate 1 whole hallway. All right, so there's 3 students, right? And if they can each decorate 1 hallway, how many hallways are left over? Well, we know there's 5 hallways, so there's 2 hallways left over. Sorry, guys. All right, so two hallways remain after they each decorate 1. So how much of the 2 remaining hallways will each student decorate? Well, there's 2 hallways, right? And I'm dividing it equally among 3 students. I could do this, all right? I know that 2 divided by 3 would be 2/3. Okay, so this would be left over. They can each decorate 1 whole hallway and then 2/3 of another hallway. All right, write a mixed number to show how many hallways each student will decorate. All right, so a mixed number, I'm going to take my whole number, 1, all right, and 2/3. All right, calculate using remainder notion. 5 divided by 3, all right, equals blank, remainder blank. All right, so I need to figure out how many times does 3 go into 5. I know it's 1 time. All right, and then what's left over? 2. 1, remainder 2. We're not going to go into this, all right, because I think this is long enough. If you guys need any help or extra help, please reach out to me on Zoom. Yeah, and that's it. You guys did a really good job on yesterday's assignment, so if you need any help, just let me know.